In order to better understand the filter circuits, we need to see how resistors, capacitors and inductors behave when an AC signal passes through them. Here we have created a voltage divider similar to the ones we have discussed in previous tutorials. Two resistors of equal value are used, but instead of a DC supply we will use the AC supply. Now when we play the simulation and use the waveform viewer and view the signal source, and we can see we have a 10 volt peak to peak signal. When we view the signal between the two resistors, we can see the signal has dropped to 5 volts peak to peak. The signal is divided in half as expected, and we would expect the same to have happened if the power supply was DC. Resistors act exactly the same way in an AC circuit as they do in a DC circuit. Let's now try a resistor-capacitor circuit. A capacitor will oppose the flow of AC current. This is called capacitor reactance. Capacitor reactance is measured in ohms. Capacitor reactance is shown in an equation by the letters XC. Although the reactance is measured in ohms, it is important to note that it is not the same as resistance. Reactance will change as the frequency changes. In this sample circuit, we have a 10 Hz signal, 10 volt peak to peak AC power supply, a 50 kilo ohm resistor and a 1 microfarad capacitor. To find the reactance of the capacitor, we use the following formula. Xc equals 1 divided by 2 pi Fc. So capacitor reactance equals 1 divided by 2 times pi times the frequency times the capacitance. We will use the value of pi to the first two decimal places. Pi equals 3.14. 2 times 3.14 equals 6.28. Frequency is 10 Hz and the capacitor is 1 microfarad. 10 Hz multiplied by 0.000001 farad equals 0.00001. 6.28 times 0.00001 equals 0.00000628. 1 divided by 0.00000628 equals 15923.56 or 16 kilo ohms. Capacitor reactance is 16 kilo ohms. Notice the difference in the input signal and output signal. The output sine wave is out of phase with the original signal. As the frequency increases on the RC circuit, the reactance of the capacitor decreases. Let's replace the capacitor with an inductor. The electromagnetic field which surrounds the coil induces a current in the opposite direction of the original current. This is inductor reactance, and it is also measured in ohms. Inductor reactance is represented in an equation with the letters X and L. In this sample circuit, we have a 25 kHz source, 5 volt peak to peak AC power supply, a 500 ohm resistor, and a 5 Henry inductor. The equation we use to calculate inductor reactance is XL equals 2 pi FL. Inductor reactance equals 2 multiplied by pi multiplied by the frequency multiplied by the value of the inductor. Pi equal to 3.14, so 3.14 multiplied by 2 equals 6.28. 25,000 Hertz multiplied by 5 Henries equals 125,000. 6.28 multiplied by 125,000 equals 785,000. So the inductor reactance is equal to 785 kiloohms. As the frequency increases on the RL circuit, the reactance of the inductor increases.